Further discussion on integration concepts. So we'll move on desktops. This is Linux Mint. Okay, so integration is simple concept, but if understandability is not good, then it can make life hell, because as it progresses, things will become complex unnecessarily. Okay, so what we have seen, addition is collection of items. We collect item in each unit of time. Multiplication is large scale addition, and integration area based addition. Okay, so this is kind of continuous addition, that is also it is called. Like if collection of balls is 7 every day, after 5 days it is collected this much. So 7 plus 7, okay, so that comes to 35. Or if collection is ball is too many, like for 395 days it is collected 7 each day, then addition is not possible and it comes to into 398, that is this much. Okay, there can be many ways we need addition. So this is large scale addition, this is small scale addition, so we'll go for addition. Large scale addition, that is multiplication. This can be one funny way also, like 1 plus 2 plus 3 plus 10. So we can write like this and we can reverse and we can write like this. And if we keep adding, then it will become 11 plus 11 plus 11. So 11 into 10 times by 2, because we have added one more line. So net is 11 into 5, that is 55. So it is far easy than someone start calculating 1 plus 2 plus 3 plus 10, he'll go mad. And if it is bigger, then just you can think about it. Okay. Okay. So, so far we have seen like this, like, okay. So, if we see graph wise, so we demonstrated unit wise, and if we see graph wise, so collection of 7 oranges, okay, for 1 day, 2nd day, 3rd day, for 5 continuous days. So this can be a graph, and this is the scenario. So 7 is a kind of a constant, and everyday collection is constant, and for 5 days, so this will be a graph. So if I calculate the area of this graph, then it comes to 7 into 5, x into y. So that much is collection. So area of the graph is nothing but multiplication, or means this is how the addition in graphical form. Or a person collects 5 kilometers every year, then at the end of 7 hours he collects 35, because x is 7 and y is 5. So 5 into 7 comes to 35. So this is also a way of addition. So if I know this is independent variable, x-axis independent variable, okay, so time just passes through, and y-axis is how much kilometer he is collecting, means he is walking. Okay, so this is dependent variable, and if it is constant, every year the collection is constant, then it will lead to this kind of a rectangle, and calculating the rectangle is nothing but the total addition, total collection. So that we can say 5 plus 5 plus 5 7 times, or 5 into 7, whatever comes to mind. So this is sometimes referred as kind of speed also. 5 kilometer per hour is speed. Actually it is 5 kilometer total collected during 1 hour. So that is also called 5 kilometer per hour. Okay, so three cases we saw. This is addition, this is multiplication, and this is what we saw, 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 10. So these are drawn in a graphical form. So there can be in first hour collection is something else, second hour, third hour. So this we cannot use multiplication. Means this is not a kind of homogeneous. It is not a smooth. It is not a same every duration. So multiplication cannot be used. Okay. So this is purely addition we have to use. We have to add this, this, this and this. Okay. So this is. So this is addition. This so this is addition. Whereas this is multiplication, it is constant multiplication, and whereas this is, we can say just addition, this is also addition. Okay, but the way it is done that we have already seen. So it can be added in this way. Okay, so these three we saw. Now we'll proceed. So we'll proceed towards low. If I know the calculating the area, but all three are based upon the area. This is the first case of the area. Okay, the way we calculate the addition is different. Here addition is calculated like this. Here addition is calculated like multiplication. Where here addition is calculated in another funny way. But we can, if we go, but all can be represented through area. And if I get the area, then total addition is done. So that is the scenario. Okay, so we'll proceed more on it. So suppose this is a full rectangle from right to left irrespective of the color. Now this color is growing. Okay, so this color at a moment it is at X, where X is moving. Okay, now what is the addition till X? Okay, so at X is here and X will be here. If X is here, sometime later, okay, so X can be okay, so sometime later X can be here. Now this is growing always. The way we have drawn, this is growing. So X is shifting one place to other place. So what is in discussion now is at any X, what would be this addition or what would be this area? So I would say if it is 5, if this is 5 km per hour, or we can say equation as 5. So we can say this as, if this is X, then this can be denoted as Fx. If that is x, so this can be denoted as fx. So for varying x, what would be the area? So that is nothing but 5, that is 5, fx is 5. So x is independent variable and fx is dependent upon the x and it is a function. So function is 5, it's a constant. So 5 into x is the area. Now we can denote it as like this also. Or we can write like this also. But actual denotation is this. So 5 we would integrate up to x. This is integration. Means integration is nothing but calculating the area, and that area where, okay, so this is dependent variable and this is independent. So independent is range, okay. Now it is 0 to x, from 0 to x. So we can say just x and fx is 5. So we can insert fx in between. Now I can write here okay. So can we see that 5 into x okay. So can we see that 5 into x, so 5 is fx and this is x. X is independent variable and this is dependent variable. Dependent variable came inside and independent variable went up. So this is how multiplication, or we can even change it more. Okay. So now I would say equal to okay. So I can write here as five plus 5 plus, okay, like this, plus 5 plus x times okay. Now first we have addition 5 plus 5 plus 5 up to x, up to some time, that is converted to 5 into x. It is added up to x time, that is converted to 5 into x, same thing. Now it is converted into integration kind of notation, nothing more. So 5 is converted to fx and x became like this. Fx is nothing but 5 only. So it is like this, and then it is 5 and x. So we add dx. Okay, just we can say that just as a kind of we believe that it is varying in x direction, nothing more than that. Okay, now same thing. Now a person is walking 5 km per hour, and between x and y, how much he has walked. Okay, so that is the area. That is 5 into y minus 5 into x. If I say 5 into y, this is this area. 5 into y is this area. And if I say 5 into x, then it is this area. So 5y minus 5x, same thing. So first is bigger area, next is smaller area. So if I do the subtraction of these two areas, then it leads to this area. So this much he walked between yr and xr. So now I can say 5y minus 5x. 5 dxy minus 5 dsx. This is nothing but, this is not a natural way. This is the notation. This is how integration notation is mapping to the area. So we are learning how integration notations are. So 0 to y is this area, bigger area, and then 0 to x is smaller area, this area, what we see in green color. If I do subtraction of these two, then this would lead in between area. So now I can write in integration x to y fx, that is 5 dx. If someone is writing 5 dx x to y means up to y one area, up to x one area, and then subtraction, that is intersection area. Okay, so this is clear. Okay, so now we'll see another form. So basic form we saw that if it is a kind of a rectangle, if it is a constant, this speed is constant, then it is a rectangle. Whatever speed is varying, now it is moving, the person is kind of moving at a speed of 5 by 2 per hour. Means at 1 hour his speed is 5 by 2, that is 2.5, and at 2 his speed is 5. Okay, so he is accelerating, means he started from the rest and then he is walking, he is increasing his walk speed. So it's not like this, it is constant. Okay, so we are seeing a third form, like we saw that addition is nothing but area. Then this is one form of addition when it is not constant, where multiplication is constant, and where we saw one funny way of addition that leads to a triangle where it is 1 plus 2 plus 3. So this triangle we are talking now. So a person's speed is not constant, speed is growing. Speed is growing at 5 by 2 per hour. Okay, how much distance he has collected in 2 hours? That is the area. If he is collecting distance at a speed of 5 by 2 into h is this axis. H is independent variable and fh is 5 by 2. So fh is 5 by 2, then if I calculate this area is total distance travelled by this person in 2 hours. Okay, how much distance he has travelled in x hour? Okay, so that would lead to a bigger area that he has travelled in x hours. Okay, so how much he has travelled in XR is full, or rather I can say how much he has traveled in XR is full. Okay, so in 2 hours, in 2 hours he travels this area, then in X hour the full area he has traveled. Now we have to find. Now if I see closely, then this triangle, and if I make it kind of opposite, then this triangle, both are same, means both have same area. This full leads to a rectangle. From here to down it is a rectangle, and rectangle height is 5 by 2h. At any moment height of this rectangle is 5 by 2h, and at 2 second hour it is 5, otherwise it is 5 by 2h. If it is 5 by 2h, then area of rectangle is 5 by 2h, that is the height, into width h. Now if I talk about the triangle, then divide by 2. So area of this triangle is area of the rectangle divided by 2. In integration notation, we can say that, okay, so this is for any h, we want x. So I can say fh dh, and up to x. We want to calculate up to x. So fh is 5 by 2h. So f5 by 2h dh up to x. If I take out 5 by 2, then h dh, only variable inside. This becomes this, because I know this. This becomes this, because already I know this. This is the rectangle. So this becomes this. If this becomes this, can we come to a formula where x to the power k dx, if I calculate the integration, it becomes x plus k plus 1. That is what we see here, k plus 1, and by k plus 1. Okay, so h to the power 2, so we started with h to the power. So if h to the power 0, if it is h to the power 0, so in rectangle it is constant. So if it is h to the power 0, then it becomes 0 plus 1, 1, and 0 plus 1, only x. So that's what we saw. So this area is only x. So 5 dx, okay, 5 dx is nothing but 5x of this integration. So that becomes only x. If it is 0, if it is 1, h to the power 1, this is what it is, then it becomes h square by 2. That is x plus k plus 1. So for k is 0, it is valid. K is 1, it is valid. So this is the area. So what we are trying to find is what is the integration for the basic shapes. So if it is constant, if it is a rectangle, then it is the constant. So it is x. If it is a triangle, then it is x square by 2. So we come to this. So this way we can deduce a kind of integration of basic shapes. So bigger shapes, they are derived from integration of basic shapes. Okay, now what is the area between any x and any y? So as per the integration, okay, now the way we talked here, between any and x and y, so this area between x and y we have to subtract. So that is the same thing we'll do. So this is the formula. So area between y minus area between x, that will lead to x to y fh dh. So that will be 5 y square into 2 plus 2 into 2, 5x square. The way we deduce the formula. So integration between x and y, any x and y, please don't concentrate on dh. dh just say what is the variation. Okay, so we can remove dh also. So if I see this integration of 5 by 2h between x and y, so that is for y and then minus for x. So this is what we have seen here. For y whatever we get, for x whatever we get, we have to subtract if it is x to y. So we subtract and we get like this. So now we have complex shape. If it is complex shape also, everything, all the basics, it stands same. What about sin t? If variation is, now a person is walking and he is reaching apex here, means maximum speed, then he is decelerating, he is reducing his speed, and at pi r his speed is 0. How much distance he has traveled? So, if this equation is sin t, then it is nothing but 0 to pi sin t. So, if I say that integration of sin t, the way I say integration of xk is xk plus 1, if I say integration of sin t is minus cos t, then integration of sin t, whatever we see, 0 to pi. So, that will come as minus cos pi minus cos 0, that is 2. So, this person has travelled 2 km if he travels in this fashion. If he travels constant fashion, then it is just area of that. Anyway, area of everywhere, it is area of rectangle. If he travels this way, then area of a triangle. And if he travels his sine wave, then area of the sine wave. So that is nothing but is integration. And then upper limit and lower limit we have to subtract. What about this? A person, he is walking, okay, and then from pi to 2 pi he is walking like this. So negative walking means he is coming back. Okay, so negative walking is coming back. Okay, positive walking means he is walking forward, whereas negative walking means he is coming back. So this is the question. So if it is like this, what would be, how much distance he has traveled? So from here to here, he is walking forward. From here to here, he is walking backward. So here, total distance he has traveled is 0. Here, total distance he has traveled. Then here, he has total distance he has traveled separately. But if we calculate both, add both, it is 0. That is sin t dt from 0 to 2 pi. So cos 2 pi minus cos 0, that becomes 0. So it is perfect. The area is perfect. Now in better interpretation we see, so person is walking forward in this duration and person is walking backward in this duration. If that is the case, then total kilometer walked is 0, whereas for 2 pi he walked 2 km. So in this reason, we say he walked, even though he walked 2 km back, but it is minus 2. So minus 2 km. Okay. So that is okay. So this is how it is. So we'll see the lapses. So we started with kind of addition is collection of item, multiplication is large scale addition, where integration is smooth addition, continuous addition, or area based addition. This is simple addition. This is bigger addition in the form of multiplication. This is another way of addition. So simple addition, okay, that if so, addition in the form of area, that becomes multiplication, and various forms of addition. So this is discrete form, we can say. This is continuous form. This is another discrete form in a triangle shape. Okay, how addition, we started with addition, it shifted to multiplication, then it shifted to integration. Integration is nothing but just giving a sign, but it is Internally it is area. So this integration slowly leads to this. Now integration is finding the area. We can find area between a range. So that we can denote like this, x to y and its function. Okay, so integration fx is the dependent variable and x is independent variable. So independent variable we also call range. From one range to another range, that different we denote like this, x to y, and y f5 is fx. If fx is triangle, then it is like this, and then it leads to a formula of a triangle or any x. Okay, we can have a range in triangle also. Then we went with another formula, that is sin t, and we found the area, and then we say how much kilometer this person has walked. Okay, so we'll see lab.